Oh, you're back for part 2 of the extra ways to differentiate. Yep. Well, you're in the right spot because today we're looking at 9K, which is the quotient rule. Yep. Now, the good news is if you have a function and it's divided by another function, provided that each of those functions can be differentiated, then you can get the derivative of that whole function, which is a quotient because they're being divided into each other, by using the following rule. Yep. So the derivative of big F, so big F dashed x, the derivative of this is this second function, g of x, multiplied by the derivative of the one on the top line, which is f dashed x. Take away the function on the top line, which is f of x, multiplied by the derivative of the one on the bottom line, which is g dashed x, divided by this function here, g of x, that whole function squared. Yep. And notice here they've put square brackets around it. That whole function there needs to be squared on the bottom line as part of this here. Cool. I like it. All right. Now, again, there is a proof. Happy for you to read. There is Leibniz's notation, which some people prefer. Yep, I don't mind it myself. Yep. So again, if you've got y equals u over v, where you've got a function on the top and divided by another function on the bottom, then the derivative dy dx is equal to v multiplied by the derivative of u, take away u multiplied by the derivative of v, all over v squared, so that what's on the bottom squared. Yep, so same thing, just the different notation. Yep. Now, it says here, calculate the derivative of the following. Hopefully you can see here that there is a function on the top, I'd call that u, and there's a function on the bottom here, which I'd call v. From there, I'd actually work out the derivative of u. Derivative of u is obviously 1, and then you can also work out the derivative of v, which is obviously 2x plus 4. Once you've got each of those, you can plug them into the formula here, writing things out carefully. So writing out v, which is this, multiplied by derivative of u, which we said was 1. So that's why it's this multiplied by 1 is just that. Take away u, which we said was x take away 2, multiplied by the derivative of v, which was 2x plus 4. On the bottom line, you've got v, so writing it out, which is this function here, and that's squared. Yep, so it's just a matter of carefully writing it all out. The tricky part can be simplifying it all down. Yep, so again, making sure that you get things right. Take your time with that. You will get an answer at the end. This one here, no difference. Again, you're going to have a function on the top, you're going to have a function on the bottom. Yep, you need to calculate the derivative of each of those. I would then write out the quotient rule very carefully and substitute in each of those into the right spots. Again, you're going to have to rely on your skills from earlier in the chapters where you are simplifying things down. Yep, so you might need to review if you can't remember how those things happen. Yep, eventually you will get the derivative there. Same difference here, function on the top, function on the bottom. Calculating the derivative of the top line, calculating the derivative of the bottom line, applying it into the product rule, and we get the solution there. Yep. What I would definitely be doing is, before I'd write in my summary note, a little fun fact here, how you can use the quotient rule to find the derivative of tan theta. Yep. So just a little bit of a side note. Remember, tan theta is the same as sine theta over cosine theta. Hey, that's a function on the top divided by another function. You could use the quotient rule, which we just did. Yep. Put it all in. Whoop. Don't need to scribble on it. You end up with 1 over cosine theta squared, or cosine squared theta, which is, as we said, the same as sec squared theta. Cool, so that's a nice little fun fact there. I would definitely be writing out this quotient rule, fun summary notes in your fun booklets. Cool, smash through that, 5 minutes, record time. Bye for now.